Okay, this is my agenda. The introduction part I have said that I'm software developer from BD, and I'm interested in deep learning, and I like the framework of TensorFlow and PyTorch, and I use both of them a lot, and I think both of them has some advantages and maybe some disadvantages. Though to be honest, that nowadays I think PyTorch is a bit more popular, and but still, for example, using TensorFlow, you do not need to write the input dim for each layer, which is a feature I like. And also I like TF records. This is especially useful for handling large data sets. Okay, for the summary, for this competition, I have read the post after the contest finished, and I see that there are too many methods like the seek to seek based methods and CDC Boolean based method. For my patch, I'm using the Boolean CDC based method with encoder only model, and my solution is one single and deep enough model, which achieves the third place results on the learn bot. Uh, okay, I will show more later. So first let us see the training methods. So the training structure here is that you may need to run more epochs. Like for me, I use 400 epochs, and I'm using AWP from the 60 epoch, start from the 60 epoch, and I'm using batch size 120H with max learning rate 0 0.003 to 2.003 with linear learning rate decay scheduler. And I used both the train and the supplement data set. That means I just mixes the train data set and supplement data set, and I set the supplement data set with a loss rate to be 10%. Uh, this is might be interesting. That I found that it helped a lot for the performance, as you get more knowledge from the supplement data set. Especially for the CDC based method. For the 626 method, since the data set distribution might be not might be default, I do not get good results at the beginning of this test. Okay. Then I after training with the mixed data set, I will fine tune on the train data set only for 10 epochs, with less learning rate. Uh, okay. For the framework, I use the TensorFlow at first, but switch to Touch. This is mainly because I translated the previous Sun competition first place code. I use that code and use that encoder at the beginning. And I translated to Touch, and I found that TensorFlow is 3 times slower than Touch on my GPU. I'm not sure what happened. Might be something due to driver or some other issues, but I could not solve the problem. So I changed to use Touch, and also I found that there are more open source code of ASL frameworks like the NEMO or ESP9. So I think that if you do the environment, it must be faster to switch to Touch. Okay, and I also found that we could translate touch model to create using NOBUCO, which means that I do not need to manually write the translation code, which can help the process a lot. And for the dataset part, like the pre-process and augmentation, I'm still using the TensorFlow and the TF records. Okay. For the important and interesting findings, okay, firstly, the pre-process part. The first is you do not need to throw away any frames without hands. This means that even though hands is important, there are other features that might also help a lot for the prediction, like the face out and other gestures. And also, secondly, that we could use as much info as possible. For example, hands, lips, eye, nose, and pose, and also the X, Y, Z. For Z is also important. Although the data set said that we might want to ignore Z, but we found that Z is important. And I also noticed the previous competition, the first place code, he is also using the Z dimension. And also for this competition, we should use more frames. For me, I use 320 frames. I see many other teams might also using even more frames for model training. And also for me, I use a regional feature and also as well as the normalized feature. I find that the normalized feature helps the model converge much faster, but the original feature also helps a bit. And also, I'm adding the absolute precision for each frames, like 0, 1, 2, and with a divided of 10,000. Uh, so mainly, I'm using the 769 uh, input themes for fits. Yeah. For the augmentation part, yeah, the augmentation is very important. I learned a lot from the code of the previous first solution code, and I borrowed some of the code and ideas from his patch. First, and I do some experiment to see that there are some parts of the augmentations, which is the most important is the time scale. Yeah, so interpret one dimension. Uh, this is very important. Another is the time dim mask. Also for me, I use the heavy mask here, which will mask some of the time sequence, just like the code of the previous competition. Also, I add one time dim mask, which will randomly mask 50% of the frame. I found that the heavy mask here help a lot for the performance. Maybe also maybe this is very important for the CTC method, because for CTC you output independently and you do not have the language model info. So with heavy mask, you force your model to learn some context info, like to predict some of the characters, just using the context frames, not the exact frame. And also, there are some other augmentations like the alpha aug, like shift and scale. I'll use this, and this is also very helpful, especially for if you train with more epochs. Uh, I did not use the cut mix, which might help performance. I think cut mix seems to boost the performance a lot for some of from some other solutions I see. Okay. From the post, I know that some of the top teams use PostDeal. I also use PostDeal, and from their solutions, I see that they are maybe output for some of uh, the output, they will set it to the specific pattern output pattern, and they say that maybe it is due to that some of the videos have corrupted input frames. I also found that the PostDeal is helpful, and I'm using another way, like to adjust the path prompt for the CTC model. Um, you see that for the pad prop, if you enlarge it, that means you output less characters, and if you make it smaller, that means you output more characters. So here for me, I will set it to judge if the pad prop is larger than 30%. If not, then I will choose to set it to 0, so that I will tend to output more characters, which means that the model itself is not very certain for output of the pad character. Yeah. Okay, so for the model, okay. So for the model part here is my the model structure. You could say that from the beginning that I'm using the input frames with image reset. I set it to 320 frames, and I'm using a simple linear and embedding layer with batch now. So now here it has 320 frames, and also with input dim 200. And you could say that I'm following the script former structure. I use two script former main blocks. First is last script former block, which is light. I mean that it is for the bottom of my model because it handles all frames. So with self attention dim height 32 and self attention height 4. And I'm using a time reduced count downsampling. So here the downsampling is important because you could allow your model to handle more layers as well. In the same time, your model can perform well because your bottom model still handles more frames like 320, and for the upper layers, it changed to model for only 160 frames. So the model can run faster here. And for the upper layers, I'm using script former block with a different parameter set with more self-attention height. Here it's set to 8. And after the average down sampling, it is come to 80 output features. So with linear layers, and I'm set it to the it get to the vocab set, and now it can be run with CTC loss. Yeah. So here is my model structure. Yeah. I'm using this CTC only because for first in the because I do experiments at the front for the two popular solution. One is seek to seek and one is CC based, and they achieve similar results. And I thought that for this competition, the metric is for the character aware, so that might be give more advantage to CC method. And with CTC method, as you are decoding faster, you could make your model larger and deeper. But maybe I say from other solutions, maybe this is the wrong decision. But I'm following this idea only in this competition. Okay. For the model part, so I'm using script former. For me it works best. But the conformer is also works very well. So script former is just a bit faster. So make you allowing you to use more layers. For example, in order to make the net deeper, I use one downsampler layer to reduce frames from 320 to 160. Yeah, this is mainly helpful for allowing more encoder layers and using more complex encoder layers. The third part is the relative position encoding. Oh, this part is really affects really performance so much. I did not notice it at the beginning, but After some experiments, I found this part is very, very important. You remove the relative precision encoding. Yeah, it hurt your performance a lot. But I found for some of the relative precision encoding is very time cost. I found that the rope by Su Jianlin perform best for my part, and it is super fast. So I borrowed the code from Hugging Face implementation. But maybe there are some other state of art position encodings. So here relative position encoding is an interesting patch. And for the dropout is also very important. So I nearly not use any other dropout, especially for the classifier, the final classifier layer with 10%. So I do not use dropout for other layers, but I'm using that the dropout for the last part is that stochastic path. I'm using this one. This is also I learned from the first place solution of pre competition, where his code he is using the dropout with the input of noisy shape set. So I did not notice, and when I converted his code to touch, I did not notice that it is very important. At first, I only converted code to use a simple PI touch dropout, and I found that the conversion of my code is not as well as his, because with everyone, especially in the later epochs, his code was much better than mine. So I noticed that the noisy shape affect match. So after some experiment, I know that the stochastic path effects, and after I changed the dropout to with noisy shape. I changed it to use something like the instance is dropout. I implemented. I found that the his code and my code, one in TensorFlow, one in Touch, work the same. Yeah. So this means that the stochastic path is very important. So for each squeeze former block, I'm using like here for each layer, I'm using the instance drop, use the stochastic path, and also I will give a 50% drop ratio here for the later layers. So the it also